To our first session of the day, Cognitive Computing, the Rise of Self-Learning System. Cognitive computing has just started permeating into our lives and is taking small steps to transform business model in the industry. Its use case studies are not limited to speech, image, and voice recognition, but also encompasses scenarios in modern medicines, banking, and bioinformatics. Cybersecurity is also trying to tap the potential of cognitive computing, leveraging artificial intelligence, machine learning, and deep learning. So while the expectations are high from artificial intelligence and self-learning system, let's just wait, watch, learn, and discuss the myths and realities of these systems for cybersecurity. To moderate the session, I would like to call on stage Mr. Srikanth, Senior Vice President, IWFM India, and Co-Managing Director, DXC Technology. I would also request the panelists for this session to take their seats on the stage, please. May I call upon Mr. Partha Talukdar, Assistant Professor, IISc. Mr. Priyank Swaroop, Principal, ASIL Partners. And Mr. K.R. Faldu, Chief Data Scientist, Imbibe. The stage is all yours, sir.
Good morning. I think that energy is not enough. Good morning. Okay, thank you. And first of all, Ashok and Rama, thanks for inviting me. Mr. G.K. Pillai, it's a fantastic inauguration session. Thank you very much. So I have wonderful panelists with me, a combination of academic, practitioners, and industry veterans. So my job is to really facilitate next 1 hour, 10 minutes panel discussion. Before that, I would like to set the context on cognitive computing and its implication or opportunity in cyberspace. But I'll really set the context here. I'm not a content specialist, neither on cognitive computing or on cybersecurity. And we are not going to do a conclusion in the panel discussion because we only give certain perspectives and certain opportunities and certain dimensions. And we have a lot of specialists sitting in this room. I'm very sure you will conclude many of the key takeaway in the coming sessions connecting to what we are going to share. Then coming back into my 25 years of experience, I worked in automobile, FMCG company like Britannia, where I was the CIO. Then I worked in product companies like Computer Associates for 10 years, when Computer Associates gone through a huge transformation. And currently, I'm the co-managing director as well as global head of people supply chain management for DXC. So my experience in cognitive is not from technology. I was a psychology student. I did my graduation and post-graduation in psychology. So I remember in my first year of psychology, we studied a concept called general psychology. It had around 17 chapters. And all these 17 chapters are the foundation for cognitive computing. So that's what I want to relate in my 10-minute speech as well as in some of the discussions in the panel. So if you really look at, I strongly urge all of you go back and I know all of you are technologists, but really need to understand cognitive computing. You need to go back and read some of the foundations of cognitive behavior of human. So it's in 17 chapters is wonderful. It starts with learning. What do you mean by learning? How do you define learning? You might have heard about Pavlov's classical conditioning, Skinner's operant conditioning. So when I started working in technology world, especially last 3 to 4 years, when I interacted with my big data scientist and machine learning specialist and artificial intelligence, the foundation is really coming from this cognitive psychology of learning, emotions, intelligence, perception, attitude, motivations, aptitude. These are 17 chapters. You really should read it and you'll find wonderful insight how it can be applied in a technology space and how you can leverage that to drive business results through artificial intelligence or other aspects of cognitive computing. So that's what I learned a lot. That got me here in terms of application of AI and machine learning in the business which I had today. The second one, the credibility is not from cognitive computing or from technology. It comes from my customer interaction over the last 4 years. As a head of India, as well as the global leadership of DXC, I met more than 400 customers over the last 4 years. And some of the customers are CEO who visit India, and some of the customers are CIOs, and some of the customers are business practitioners. So in all this customer discussion on technology, business, then how they are helping their end customers, we discussed a lot on cognitive computing. And they said, the way you do business today is not helping me. I would like to know how you are going to adopt automation or robotics or artificial intelligence and machine learning in the offerings and services you are going to give, and how I'm going to get benefited. So we had a lot of discussion over the last 4 years in my role on how do you really adopt cognitive computing in the offerings and services what we give to our end customers and the immediate clients. So that's what I want to share. In this context, what I would like to share, first one is, since we are talking about DXC, I'll take 30 seconds to explain who we are as a company. DXC is a merger of two giants. One is Computer Science Corporation, which is around 60 years in computing space, and HPES, again, close to 70 years in computing space. Again, HP is a merger of many companies, Compaq, EDS, and HP Core. So HPES and CSC come together 1 year back, and we are in existence from April 3rd as DXC. So the logo or the tagline we use it in DXC is, we are new but not born yesterday. We have been in business of computing, including cognitive computing, over the last 70 years. So that's where who we are. Some of the interesting statistics about DXC, we are a $25 billion company with HPES and CSC coming together. And we have traditional and modern applications and offerings and services. When I say traditional, it can be IT infrastructure or traditional applications or BPS. And we also work on digital offerings. You see, we have close to $4 billion of revenue coming from digital. And many of these offerings are around cyber security. We are one of the biggest cyber security practitioners, close to $1 billion revenue coming from cyber security. Then big data and analytics, social, mobile, cloud, and other digital offerings we have. And in India, we have around 53,000 employees, and we are rapidly growing. And Ashok requested to address some of the growth and some of the concerns today our IT industry is facing around layoffs and graduates are not getting any more jobs. So I'll address at the end how we are going to address that. So this is what DXC is all about. A new company with a lot of learning and experience and offering, serving 6,000 enterprise customers across the world. Out of the 6,000 enterprise customers, close to 400 are Fortune 500 companies. We support Coke, we support General Motors, we support Toyota, we support GE, you name anybody, across the offering, including cyber. For example, Toyota's entire cyber for Americas and Europe is managed in a SOC in Noida. We manage the entire their cyber security from Noida. So this is who we are. Now I want to switch gear on cognitive. So the objective of this panel is not to deep dive into cyber security, but set a stage on what is cognitive computing and what are the opportunities, what are the myths, what are the realities, and what are the skills deficiencies in this space which industries is facing, and I'll also cover a little bit on cyber. So the basic concept, as I mentioned, cognitive is all about learning. How do you enable machine to learn? And in order to machine to learn, the machine also learn the way human beings learn. Through trial and error, through stimulus and response, through experiential learning. So how do you really make machine to learn, building right algorithm, and use that learning to improve performance and efficiencies and productivities and innovations for our end customers? That's the fundamental concept of cognitive computing. The second one is, how do you make machine think, or how do you make machine intelligent enough to respond not to transactional activities, but also predictive as well as intelligent activities and get benefit to customers. So second key word of cognitive computing is artificial intelligence. The first one is machine learning. Not only the learning as well as intelligence, the machine also have a lot of other capability like sensing, perceiving. It is also emotional. The machine also can be emotional, like bot chat, what today, it sends through your chat, understand, are you angry, are you happy, or are you concerned? So the machine learn, machine develop intelligence, and machine is very sensible like human being to respond to the processes and productivity and innovation expectations of the industry. That's a good combination of creativity as well as intelligence and learning into the technology. The technology can be big data, the technology can be cyber, the technology can be social, mobile, or blockchain, or no-click, or whatever you call it. How do you really leverage these two aspects and drive efficiency and effectiveness for our customers? The next one, it's a very interesting analysis we are doing it. You really look at how computing world has evolved from mainframe, we call it as on-premise computing, to personal computers or client servers, to distributed computing, to internet, to web-based computing, and today on cloud. In this journey, we have created tons and tons of data. And the early part of this evolution, most of the data are what you call it as structured data. Today, in computing, we have more unstructured data. Today, 80% of the computing data is unstructured, which comes from social media or text or contracts or emotions and perceptions, and a lot of such data is available. And industry is not only struggling, like GK Pillai mentioned, in securing and using this data for advantage of professionals like big data scientists or cybersecurity practitioners. So that's where the opportunity, that's where the threat, and that is where the ambition lies in terms of going behind this unstructured and structured data, and how do you create enough intelligence, enough learning, and enough emotions to respond to the customer needs. So I'm not getting into the details of this. If you really get into this, what cognitive computing does is all about understand a particular phenomena. It can be any industry phenomena, automobile or pharmaceutical or healthcare. How do you really understand the phenomena? And how do you assign reasons for this phenomena? That means how do you create a context for this phenomena? Without context, a phenomena is not explainable for a business or a customer or end use. Then how do you really interact with different stakeholders using this data or context? And the last one is how do you continuously learn and adapt to the new business challenges and expectations. In the right side, there was a survey conducted asking many of the CEOs and senior leaders, how do you find cognitive computing to the benefit of the industry and customers? And you could see 65% of the respondents say adopting cognitive computing is very important for organizational strategy. And they do recognize that it's so important, like, Ms. GK Pillai, it doesn't matter, it's fertilizers company or it's IT company or automobile company. Every industry leader said adopting this cognitive computing is very essential for my strategy of the business. Then I'm not getting into every details, I'll leave the slides behind. Then another one is cognitive computing will unlock hidden value of their organizational data. And most of the hidden value come from unstructured data. So can I use cognitive computing to really understand the business and take that treasure or a wealth lying there and give the benefit to the different stakeholders? The last one, it also enabling business growth through an expanded ecosystem. Earlier the business was only contained more of an internal view, but we are in an ecosystem of stakeholders like investors, customers, employees, partners, and competition and marketplace. How do you really leverage the cognitive computing into the benefits of the ecosystem? So these are the challenges. I'm very sure the panel members will address some of the challenges by creating some of the use cases and sharing with you. So again, as I mentioned, cognitive computing have different avatars, and these avatars are in a different maturity level and different adoption in different industries or verticals. So all of us know one of the biggest usage of cognitive computing is in the artificial intelligence, which we alluded and we'll discuss in the panel. And another one is what you call it as machine learning, we call ML. Then we have in the industry of health, drug discovery, and toxicology. Again, Watson has done a lot of work around healthcare. If you go to any hospitals, Manipal or any hospitals, you'll find Watson is being used very effectively. Then intelligent chat boxes, that's being widely used in the area of consumer or a customer relationship management, as well as in HR. For example, recently we built a chat box for one of our customers in the HR space, where employees can ask any questions on policies, on programs, and chat box will engage employees. And it creates a lot of intelligence through these interactions. So I'm not getting into details. Another deep learning and fraud detection and cybersecurity is another great opportunity of using cognitive. Moving to this, so this is cognitive opportunity. What is cognitive computing? How we evolved over an evolution of mainframe to client server to internet to web-based practices to cloud, and how the data has been evolved and what is an opportunity irrespective of the industry where you work in. So that's the context. Now I want to take a few minutes to talk about how we can apply cognitive computing in cyberspace. And you are cyber specialist, and as I mentioned, when Rama and Ashok asked me to come and address you 2 days back, I went into the floors of some of the legacy HPS and CSC. I mentioned we have a close to $1 billion cyber practice, and we serve many, many interesting customers like Procter & Gamble or GE, you name it, most of the customers, we help them. So when I was interacting with them on my project team as well as the delivery team, they shared some of the very interesting facts around cyberspace and how we can apply cognitive computing in cyberspace. And not getting into all the data, there are 99 days median time to detect a breach. First of all, many companies never detect a breach, and they live with it for many years, unless some big bomb explodes and they identified it. And many of the contracts where we are supposed to identify this, it takes 90 days average to detect a breach. Second one is 21,000 US dollars daily cost of resolving a breach. So I'm not getting into details. This is a real opportunity of using cognitive computing in the cyberspace. So I remember one of the conversations I had with one of our biggest customer who uses SOC in Noida. And he said, in the SOC, you have a lot of data flowing in from my application and infrastructure. I really want you to come back and share your intelligence using this data. And we started putting some of the cognitive practices for getting that resolved. Again, Mr. Pillai alluded to this. In traditional cyberspace, we are looking for data which is like a tip of the iceberg, which is visible to us. Like it can be security events viewed each day or response to software vulnerability. These are very visible. This is what we address. But we never could go into the bottom of the iceberg, which is not visible. A tons of knowledge is sitting there. As a cyber professionals, we can use it to really resolve most of the cyber threats and opportunities there. For example, there are 720K security blocks per year is returned, which lot of content, lot of use cases, lot of insight. How do you crack this learning? How do you crack this information and data to the benefit of preventing as well as controlling incidents? Then 180K security-related news articles appears every year. Then how do you really use cognitive computing to understand and leverage for the benefits of our security professional? 100K security research papers per year is published. And we don't have access, we don't create enough learning from that and apply in the business. So these are some of the, I'm very sure you're aware of that. I thought I'll give this context. Now, I would like to take last 1 or 2 minutes. The rubber meets the road. We have a lot of challenges in mobilizing next generation skill set, including cyber, cognitive, and big data. Within that, we have a lot of challenges. And the opportunity is huge in terms of serving it. So I want to share 2-3 minutes how DXC as a company addressing this. It may be a good learning for you. You really look at technology and skills required for cyber security professionals and cognitive are a lot. I only give an illustrative here, it's not elaborative. It can be like natural networks, machine learning and IoT, NLP, like you listed many things we need to know as cognitive computing professionals. Then the technology like data modeling, data science, and a lot of other technology like Python or many Adobe and many other technology knowledge is required. So many industries are struggling. For example, we have a backlog on digital offerings. Revenues waiting there, and we are not able to exploit it because of lack of skill. Again, Ashok, you commented, where is the opportunity? One of the biggest opportunity we have as practitioners in India and leaders in India, how do you really reskill and cross-skill and upskill our employee population to really address the next generation digital and cognitive skills? That's one thing we are addressing it. The job is available. Like always we argued, employability is a concern, not employment is a concern. Employment is there, but employability in the next generation industrial revolution is a very big concern. So I'll give a very interesting experience we are doing it to address that. So here, today is an era where every day, whether it's a newspaper or a radio, we'll always get bad news that layoffs are happening, college graduates are not getting employed. If you deep dive into this, there are 4 reasons for that. The one is the skill calibration. We are not able to really get the right skills, and we need to calibrate the skills. The second one is calibration of pyramid. That means we have grown people faster than what they are eligible and got them at the middle of the pyramid without challenging them with the right content and revenue per employee. So these employees grown with the cost and sticking in the middle of the pyramid without revenue opportunity which can justify their cost. So I call it as pyramid calibration. The third one is location calibration. At DXC as a company, we are moving a lot of jobs from high cost centers and medium cost centers to low cost centers. When we move a job from high cost centers, average salary is 93K, and to India we could get it with the 12K, including security rating. So we do a lot of calibration on location. Today in India itself, we started calibrating location. We have 2 tier 2 cities. One is Shimuga, I don't know how many of you know, which is 4 hours drive from Bangalore. We have a tier 2 process and application center there. And Indore, which is, good news is Indore, you have an airport, you have IIT, we have IIM in Indore. So these 2 tier 2 cities are 40% cheaper than Bangalore or Chennai or Hyderabad. So we are recalibrating location not only US to India, but within India to tier 2 centers, and we find a lot of success in developing this. So third one is calibration of location. The fourth one is calibration of performance. Mr. Pillai alluded, the biggest energy an organization gets is at the bottom of the pyramid, not at the top of the pyramid. The top of the pyramid is always boring. Elderly people keep on repeating the same thing, what they've done in last 10 years, which may not be relevant today. So how do you energize the organization at the bottom of the pyramid? By constantly calibrating performance. You force attrition at the middle of the pyramid if they are not getting the revenue or getting the required skill set, and move the job at the bottom of the pyramid and hire fresh graduates. So 4 things we are doing: skill calibration, location calibration, pyramid calibration, and performance calibration. As a result, we find what you call excess supply in this, and how do you resolve it? By giving them a chance to reskill it, giving them a chance to resolve their performance is what we are working on. Ashok, I hope I addressed, but we can always discuss how we can do better than what we do today, and how can we stop the negative news and emotion spreading in the industry. So in this context, biggest evolution is going to happen is what I want to share it with you, and we call it as dynamic talent cloud. It's real today. Ashok, when I spoke to you 6 months back, it was very conceptual stage. Today I can give you hundreds of case studies on this. So when we announced DXC formation, we understood to grow the company, we have 3 sets of business. Legacy business, which is $18 billion. Next generation business and IP products is balanced $8 billion. So in order to fuel the growth, we want next generation skills, including cyber and cognitive, from 25% to 50%. So we know that this is not available in the marketplace in the form what we do today. So we introduced a concept called a dynamic talent cloud. I take 1 minute to conclude this. So if you really look at how the evolution of ITO, it started on on-premise networking or storage or platform or servers, then we get into remote infrastructure management, then we got into cloud. So infrastructure has moved to the cloud faster than ever before. Even application also, it was on-premise application, legacy application, from waterfall to agile, and we modernized the application and got into the cloud. And cloud application also taken over a lot of legacy application. Similarly, business process also moved from customized business process to business process as service to business process as a platform. And now it is also gone into cloud. So infrastructure, application, and business process is in the cloud today. So that shows the vulnerability for security practitioners to help the industry. More important, how do you take the talent to the cloud? The talent has been on-site, then remote, offshore. That's where Indian companies got a boom. Now the same talent is getting into the cloud, from offshore to cloud. What it means is what, I'm not getting into details of this, 30 seconds. We are teaching our managers how do you break down complex deliverables, projects, and products into simpler tasks. Once you break down into simpler tasks, like Toyota have 200,000 components, which makes a car, the success of this company is they break down into nuts and bolts and tires and tubes with a specification, and they source it with thousands of vendors who deliver at the point of assembly, not to the warehouse, and it gets assembled and car is produced in 14 minutes. Takt time is 14 minutes. So similar concept, we have to break down complex products and offerings and services into simpler tasks, and you post it in a platform where the internal employees, I call it as incorporated people, and external employees who are college graduates at the first year of their graduation to other community like Kaggle for big data and analytics, or Top Coder for coding, or Uploads for testing, how do you really give to them and they will perform? There is no job contract, only task contract. And they can perform, they can do 2 hours of task for you, 3 hours for Accenture, 3 hours for IBM, or 3 hours for Infosys. So that's where industry is moving. Our wish is to take 30% of workforce, especially next generation, through this crowdsourcing platform. This platform is ready. This platform is built on a machine learning algorithm. You could see, and AI machines, we use it in this. That's called a dynamic. It, based on the supply and demand, the rate card is changed. It divert the task in the right community based on the nature of the task. If it's highly confidential and data privacy, it goes in the internal cloud. If it is not, it gets to the external cloud. So to sum up, cognitive computing is going to change the world, and it's a real, and who gets it, not only in terms of application or infrastructure, but in business process and internal process like HR, finance, and material supply chain, the opportunity is huge. With that, I will, thanks for the opportunity. Sorry, I took 2-3 minutes more. Now I'll shift into the panel discussion. The format of the panel discussion is each panel members is not going to deeper presentation. We'll facilitate some of the questions, and they will share more of their use cases around that. And then at the end, we'll open up for any one of you to ask questions to our panel members. So I have 3 distinguished panel members. One is Keyur, then Prayank and Partha. So let me start with, any one of you can take it. We keep on talking about cognitive computing. You see any articles today, it talks about it. Is it a myth or a real? Can you share from your experience how real it is?
Okay, so I guess so before we go into what cognitive computing and use cases and all, I guess one question is whether we have a common understanding of what cognitive computing itself is, right? And what are, I mean, we keep on hearing all these words like artificial intelligence, machine learning, cognitive computing. So, I mean, maybe I can just take a few minutes to kind of lay out the terms as I understand it, right? So, artificial intelligence kind of the goal there is to build machines which can do non-trivial tasks, right? So, as a discipline, artificial intelligence has multiple components inside it. So, one is perception, right? So, when you are visualizing or interacting with the world, you have to understand what that world presents to you. Next is some sort of planning, right? So you want to achieve certain goals, and so how do you go from one state to that target goal? Then one is reasoning, right? So once you have built some sort of model of the world through the help of some knowledge that you have acquired over your lifespan, then there is learning, right? So when the environment changes, how do you adapt to that changing environment so that you can make your decisions, right? And then there are other things like communication and dealing with physical objects and robotics and all, right? So learning is one of the components of this big stack of AI, right? And within that learning, we want machines to learn. That's where machine learning comes in, right? And within machine learning also, so you can think of machine learning as one of the components of the big stack of AI, right? Then within machine learning also, there are different types of machine learning, right? So machine learning is basically you provide data and you want the machine to learn to do a particular task, and there will be some metric on which you will evaluate the performance, right? And hopefully as you, with more time or with more data, you want that performance to improve. So within machine learning also there are multiple types. So one is unsupervised learning, there is semi-supervised learning, supervised learning, and reinforcement learning. So most of the success that you see of machine learning is coming from the sub-area called supervised learning. So where you actually are explicitly training the machine to do a particular task well, right? And more recently, the term that you've been hearing, deep learning, is again one instantiation of supervised learning. There are also some recent success using reinforcement learning through games and all that you may have heard, like for the AlphaGo system from Google, right? So AI, machine learning is one component of AI, And within that, there are multiple types of learning. So supervised learning is one of the most successful ones, and deep learning is one instantiation of supervised learning, right? So with that taxonomy, now the question is, where does cognitive computing come in, right? So as far as I know, I think there is no universally agreed upon definition of cognitive computing, but the best definition that I find, I guess, like satisfactory is how, through cognitive computing, we want to build these computing platforms where machines and humans can work together to achieve certain goals, right? So with we live in an era of big data where, like, velocity, volume of data, it's getting generated in such an unprecedented rate, like including in security, that it's not possible for humans to keep up with that pace, right? So the question is, like, whether we can build intelligent machines, maybe using AI machine learning techniques, which can do some amount of the work for, like, maybe like a significant part of the work, but they can interact with humans, and then together they can solve problems which will not be possible for humans to tackle on their own, right? So that's where, and that's where you hear, like, whenever people talk about cognitive computing, you hear about we want to mimic how the brain works and things like that, right? I mean, if you think about it, why that's necessary is because you want that machine to also interact with the humans in making that decision finally, right? And if they are working in two different worlds, if they don't have a common language, right? If they don't have a similar processing goals, then it's difficult to have that harmonizing between that human and the machine, right? And so that's where I feel like, there are like lots of opportunities, like because the data is growing at such rate, and most of the data for like the use cases that we want to automate these systems, those are primarily kind of generated for human consumption right now, right? So even if you take like the security domain, so the statistics that Srikant mentioned, so you are providing these threat intelligence reports or research papers and all, those are not meant for machine consumption. Those are meant for human consumption, right? So now you are not going to significantly change that part, but what you want machines is to pick up with those data, build a comprehensive 360-degree view of the world, and then use all of that knowledge to basically do improved decision making.
Hey, thanks, Partha. So Partha's conclusion, it's really true. If mainframe took 20 years for adoption, or cloud took 10 years for adoption, I think cognitive computing will be getting adopted less than 2 years. So its adoption is very fast, it's really real, and it's going to stay. Thank you very much. Now, Priyanka, from the business you are in, how are you using cognitive computing for increasing the productivity of your own enterprises? Because a lot of organizations start cognitive computing for improving their own productivity and innovation. Then how are you seeing this is getting translated to end customer benefit in terms of newer offerings, cheaper offerings, and better offerings? Yeah.
So interestingly, the business I'm in is in investing. So I invest in startups. So that's, I believe, slightly hard for, I believe, cognitive computing to disrupt, but we invest in cognitive computing or artificial intelligence startups. And so to give some sense, Axel manages $1.1 billion of investments in India. And we have invested in a bunch of startups, including the likes of Flipkart and Book My Show, which themselves use a lot of artificial intelligence within their own right for recommendations as well as for pricing. And if you look at the use cases, for example, Axel has invested in, from India, we've invested in a healthcare startup called SigTuple. They use a lot of deep learning to identify pathology, to basically look at blood samples as well as X-ray reports, identify the problems in the blood samples and X-ray reports, and help in telemedicine. And they do it over a large amount of data, right? So they have achieved accuracies above 99%, which allows free time for the pathologists to spend more time with the patients or look at more involved cases. It allows, and that particular use case allows more bandwidth to, let's say, take that technology and send and provide healthcare across, remote districts of India, where a typical, lab assistant can just take a slide, take a photograph of it, and send it over the net. And the technology, the cloud, the artificial intelligence engine will basically look at it and report out the data And if there are any issues, then it will get flagged to the pathologist to say, hey, this is an abnormal case. We also have invested in companies, for example, actually a lot of companies are developing their own AI systems to create, it was a beautiful graph. I'll give you an instant example. One of our companies was doing some sort of pricing, so looking on data for last 1 year, data around a particular system. For example, if you are in Kormangla, let's say, how should I price my particular offering? And a lot of that, and the amount of variables and the amount of time series data available is like just enormous. And current systems which are not using a lot of advanced AI were able to resolve and look at the data only at a 24-hour resolution window. Whereas the company developed their own system which allowed pricing to change dynamically every minute. And it increased their margins by 5 to 6%. And the AI engine took a very counterintuitive, not a very counterintuitive decision there. They said, the only way to increase my profits is to actually reduce my sales, but increase my margins. So what they did is they increased the price, so the number of sales, the number of transactions you do dropped, but the margins you make on each transaction increased. And fundamentally, the company is looking at bottom line, right? So that's a very counterintuitive example, which is not, a human being will not take that decision very easily. And then the last part, we've invested in a lot of companies that are in security, I think, which is very relevant for this meet. So we have invested in over 19 companies across the world. One of them is from India called Simility, which is a fraud management company. So what they do is they work with large organizations, look at, for example, good use cases, anti-money laundering in banks and BFSI. These are all product companies. So we invest only in product companies. We have not invested in any services companies. So, and it's a great example where a very small organization with few engineers is able to assist large banks in understanding anti-money laundering and politically exposed people transactions. So to give you some sense of the problem I'm talking about, a bank by regulation is supposed to look at all transactions they do and identify by law they cannot transact with any politically exposed person, which means it could be the terrorists of the world, it could be somebody who is a known profiteer or money launderer, and banks have to look at all transactions, and this applies to this actually applies to all banks across the world. Now banks are large banks, if you look at ICICI, HDFC, if you look at any other bank across the world, they're generating tons and tons of millions of transactions happening every minute, happening every second, and the systems have to respond whether to allow or disallow that particular transaction. And the customer, who's sitting on the other side can't wait, right? You're talking about electronic transactions, you're talking about digital transactions. So now you need a system which is basically able to look at these petabytes of data and take a decision, hey, looking at all the data sources I have, looking at all the transactional trends I have seen, this transaction is okay. And this is where the similarities technology comes in, and they look at that, and they'll say, hey, I can prevent the fraud. Similarly, online retailer has to take a call that, should I allow transaction from this credit card or from this particular zip code? And that's where, again, Similarity would step in and say, hey, I've seen the data, I understand the process, I understand the customer profile, and you can allow that. Similarly, we have 3 other companies which have become very big in specifically cybersecurity per se. We have invested in CrowdStrike, which is endpoint security company. We have invested in Vectra, which is network security, so which at in real time looks at all possible endpoint devices inside the organization and sees, is there any fluctuating pattern or different pattern which is happening, and should it inform the system analyst or the security analyst about that, and take proactive action. And then the third is Demisto, which is an incident response technology company, which helps, as organizations become more complex, the amount of security incidents happening inside the organization are growing by the thousands and 10,000 happening every day, and you have let's say a company like Infosys or even the government of India has millions of computers under them, and any of them could become a single point of breach. So the number of people you can employ as security analysts are limited. So Demisto allows that intelligence to say, you as a security analyst should spend most of your time in these top 3 incidents and not anywhere else. Okay. So that's kind of stuff.
Okay. Hey, thanks. I think to conclude, you have been investing in companies in the cognitive space who are startup, and also you've seen your own investment companies has been using cognitive to improve their productivity and also serve their end customers. Thank you very much. Keyur, can you throw some light on the same concept, how you are using to improve your own productivity, cognitive computing, as well as your end customers' betterness? Yeah.
Correct. So I come from Imbibe, which is basically we are building an AI platform for education, right? So when we say education, like education is a very wide area, right? It comes like, there are like 3 pillars of education. So first is content, right? So we have to understand the content and like interpret it in, and then with the context we have to serve it. Second is the student, right? And the way currently we are dealing, like every class has, let's say, more than hundreds of students. So then it's practically not possible for a teacher or a mentor to understand the weakness or strength of each student, right? So that's where we need user modeling, where we understand each and every student in terms of behavior and academic strength and weaknesses, right? And then third comes the mentor, right? So mentor's job is very tough. Mentor has to interpret content, mentor has to understand student, and he's the bridge between them. Right? So these 3 areas, if we think, then it has to be dealt with intelligence, right? So for example, computer, like back then, computer was not able to understand, okay, what is this question, then what are the meta attributes of these questions, like latent attributes, like what would be the time that student will take to solve this, or what is the difficulty level of this question, or what are the small micro concepts this question is pertaining to, right? So in order to like just understand this thing, we need a mammoth machine learning system, right? Because just imagine if I ingest a book, digitized book, but now to meta tag each snippet of the textbook with all this kind of text, it requires a lot of massive learning, right? So that's where like each, and like it's same for student, like and student, I mean, if we want to talk about like evolution, like how this happens, right? So then it is like first we have like relational data, and then the relational data will be enriched with, let's say, structural data, like we get without the context of the relation, but like they keep on coming. But when we start tracking the temporal data and the spatio-temporal data, right, it just became insane, right? Student was at what location, what was he doing, what was he studying, and the stuff like that. And after then, the unstructured data just increased the volume. As Sri said that 80% of the data is unstructured, but I would argue that in like coming couple of years, it would be like around like 99% of the data would be unstructured or the offline data, right? Because there's like currently if you are sitting, all the data, like who are the participants and what is the weather, what is the temperature, what is the room, what is the location, everything that we see in the offline, thanks to IoT, right? That all data will come into the picture, right? And then it is open to interpretation. So that's where if we can, any vertical if we take, if we understand and if we cognitively, if we are able to interpret and infer from that, then we can create a lot of impact. And as a result, in the company which I'm working, right, so we are giving the guaranteed learning outcome. And then we have seen students getting more than 30% of score improvement within like a span of like 2 to 3 months, right? So that's because of the behavioral aspect. Let's say if student is doing careless mistakes again and again, that's the behavioral trait. We have to highlight that, and then student can fix it. If student is overconfident and in the negative marking, like 1 mark can cost him like hundreds and thousands of ranks, right? So the behavioral trait like lack of attention and then too much of like swapping between the papers and then the careless mistakes and then stamina and stuff like that. Those are like latent. You don't get it, right? You have to derive it, and once you have it, and then you highlight it and you fix it. And then comes the academic part where we serve student the bits and pieces knowledge that he actually is weak into or basically has to improve. Yeah.
Hey, thanks, Keyur. So the key takeaway here is a lot of companies are using cognitive computing to improve their own productivity, internal process productivity and efficiency, as well as they are using for their end customer or consumers, giving better offerings at a better price point and innovative offerings. That's what, and reducing the cycle time to offer it. I will share from my own experience. As I mentioned, DXC have 6,000 clients. And many of the clients today look upon us to reduce the cost of operation of application or infrastructure or BPS. For that, we are applying a lot of cognitive computing to improve productivity and cost takeout by deploying robotics or analytics or chat boxes to do that. We are also using this to really help our end customers their end customers efficiency improvement. For example, one of the very big automobile company, we do their 2 applications. Entire global, their manufacturing assembly line software is managed, developed and managed from Chennai. And they also, they have huge warranty claims, application is also maintained. So today, customers are coming and asking, hey, my warranty claim is very high and accidents are very high. You have been maintaining my manufacturing application as well as warranty application. Can you do some analytics and tell me how can I reduce my warranty claims and accidents of our end customers? So we are doing a lot of analytics and cognitive computing to really help our clients. Same with insurance clients, same with healthcare clients. So that's a key opportunity there. How do you internally improve productivity, and how do you really show your customers, their end customers, how do you drive efficiency? So thanks for that insight. The next one is, as I mentioned earlier, a lot of skill gaps in cognitive space. And its cognitive is not only, what I learned is not only technology, it requires psychological, it have data science, domain knowledge of industry, lot of other discipline. So Professor, from your experience, how are you preparing students to meet the challenges of cognitive computing from skill incubation perspective?
Yeah, I think that's a really important question, especially in a context like India, where we clearly see the needs, but the gap in terms of human capital is probably like the most biggest bottleneck. So I think to do well in this space, students need to have good background in machine learning, artificial intelligence related areas. So in areas like linear algebra, probability statistics, optimization. So in IISc, we have strong courses in all of those areas. We in fact have recently also launched a department called Department of Computational and Data Sciences, or CDS in short. So among the premier institutes in India, so this is the probably first department that's exclusively focused on data science and computational science problems. So we train students through master's and PhD programs to gain strong foundations in these areas. And then also we actively collaborate with industries to get important use cases data sets, because as Sri mentioned, having the domain knowledge and access to that is really one of the key ingredients here. And so I think working on real problems is really important. So that's kind of like a mixture of having specific programs dedicated to data science, cognitive computing, and also interacting with industry to work on real problems.
Yeah. Thank you. Keir, you have been earlier with the McKinsey, now you are in the organization. So how are you really helping your employees to reskill, cross-skill, and upskill into the cognitive computing space? That's one of the great opportunity. That's where I feel guilty as a practitioner. We're not doing enough. Only we are laying off people who doesn't have the skill set. So how are you helping your employees to cross-skill? Yeah.
Correct, because like it's been changing a lot, right, in general, right? So I would just like to attribute my thinking back then in like late 90s when I was studying, and I was first introduced to Moore's law. Okay? So Moore's law stated that every year the transistor in per inch would be doubled, right? So then then it is exponential, and if it is exponential, and if it started from like 1960s or 1940s, then the pace at which the world gonna change in like next decade would be insane, right? So that's when, if we see like last 6 to 8 years, right, it has a massive impact in terms of everything, right? We used to deal with, let's say, SQL and then the database and stuff like that, right? Every college used to have that courses, right? But suddenly the NoSQL came into the picture, and then it changed the ecosystem of the skills. So it requires the new skilling. I mean, basically, even like our universities, right, bearing the top in premium universities, like if the rest of the stuff, the long tail, they are not as adaptive to the trend, right? So many times it is a question, it is a problem that when we work in a software industry, is that we have to reskill ourselves, right? But thankfully it is possible, because sometimes it is like, without empirically, if you want to learn a concept, it's difficult, right? But with empirical data as well as computing power, thanks to cloud computing and an abundance of the data available, then it becomes really easy to resonate with the system and pick up the systems, right? So the of late, like data analytics converted to data mining, and then predictive analytics and machine learning and artificial intelligence, that's the reskilling that I think that's happening everywhere, right, from universities to industry, right? And then people are, and thanks to like education platform, right from Imbibe to Khan Academy to MOOCs like Coursera and stuff, I mean, there is like plenty of learning material which people use to learn the cognition. Yeah.
And thanks, Keyur. So one of the challenges we face as an organization is how do you really make employees learn at the pace of the business, not ahead of the business, at least how do you make them learn at the pace of the business, because cognitive computing is moving very fast and we don't have enough skill set who can learn at the pace of the business. So I think both academicians and practitioners need to come together and get that velocity and required space of learning. So last one, before I open the question related to cyber security, I was reading many articles. The cyber domain today is close to 1 trillion. By 2010, it's going to be 3 trillion. And cost of cyber attacks is today close to 3 trillion. By 2020, it is going to be 6 trillion US dollars. So here, a lot of opportunity for cyber security professionals to really help organization who is adopting cognitive computing very fast. There is a threat, there is an opportunity. So Priyank, if you can share your insight, what are the threat and opportunity of cognitive computing for cyber professionals?
So it's a very interesting domain, and like you said, the cost of $6 trillion is very high, right? So, and how do you, so it throws up a lot of opportunities. Interestingly, if you look at the adversaries, the hacktivists, the rogue nation states who are actually trying to steal IP and take away all the data, they're also applying, artificial intelligence techniques. So it's becoming a war between literally two AI machines, and I think that's where we find a lot of new. So there are 2-3 opportunities. Let me be very specific. So one is just new data is being generated, like Keyur said, from IoT, and IoT is just creating more and more endpoints. If those endpoints are not protected, if that network is not protected, they provide spaces for breach. And that's where we are trying to look at IoT devices, IoT platforms, IoT networks, IoT protocols. Any of those could throw up basically opportunities for investments for us, as well as opportunities for entrepreneurs to create new companies and evolve. Second set is obviously as the rise of NLP and chatbots is increasing. Alluding to what Partha, I think a lot of your research is in that space, right? Interesting incident which happened was Microsoft Research put their AI chatbot on Twitter, and that chatbot was made into a neo-Nazi. Also the personality of that chatbot in 24 hours was made into completely anti-human, right? And that's where we believe is another space. How do you provide data sets? How do you create data sets, proprietary data sets for all the AI applications which are going to be used? And those data sets have to be the correct data sets. That's another opportunity, which is available. And currently, a lot of cybersecurity issues are evolving around a lot of AI companies which provide data security, use data sets which themselves are, hacked into or are muddled with by miscreants, and that creates a big issue. So that's another opportunity in the short term as the rise of NLP happens. And then third is obviously autonomous systems. So the rise of the autonomous car, rise of autonomous trucks. Those trucks and cars again provide another system, and there could be much more damaging in terms of loss of life than just value. So how do you protect and secure those systems is another big issue which is available out there. So.
Thank you. So let's open up for a couple of questions from the audience. So who is the first person? Yeah, go ahead.
Yeah, hi. My name is Rohit. So since the theme is cognitive, I have a basic risk question. How do we ensure that the title says, okay, the rise of self-learning systems, how do we ensure that we don't move towards the rise of the machines, where the self-learning systems become, self-aware, and tomorrow that humans don't become redundant, right? And we don't end up like batteries like in the movie Matrix, right? So this is more on a, maybe an ethical question. What are we trying to, where are we trying to go? Why, are we making, systems that it's more intelligent than humans, and then humans become redundant then. So.
Yeah, thank you. So who want to take that?
Okay.
Yeah.
All right. So just to calm your nerves, I think we are far away from, I think, like machines taking over everything. But there are definitely real threats, right? So for example, like if you're like, going in a self-driving car, what kind of guarantees you have that like, it's not going to get into, because your life is at stake there, right? So I think like at the immediate, I guess kind of like a more direct way. So like, if you're using these AI machine learning techniques in some critical scenarios, then I think like, the risks and threats that could come out of there. So those are real, and we need to address those as best as we can. There are also lots of legal questions around them, right? So I was recently in a discussion forum in NLS UI. So like, if you have a self-driving car, it gets into an accident, like, so who gets the responsibility for like, taking that, right? So is it the owner of the car, or like the company who is supplying that self-driving car, or is it the manufacturer, or like the manufacturer of the car, or the manufacturer of the sensor, which like, malfunction, which led to some particular crash or whatever, right? So I think I mean, all those things are up for debate right now. But I think like I'm hopeful that over the next immediate future, we'll settle at least those questions.
Yeah. So I fully agree with you. From my experience, we always gone through this transition era. We came from agricultural to industrial production to service industry. Now service industry is challenged with the cognitive. So we always learned, we always accepted this change, and we always adopted to this. So one of the things I always tell our employees is really acknowledge where industry is moving. Do not deny it. Once you acknowledge it, you'll find a lot of opportunity, whether industry domain specialist requirement or architects requirement or more customer facing requirement or innovation opportunity. So we need to accept it, adopt it, and we need to acknowledge it and invest in ourselves in learning. So as managers, our job is to really taking our employees through this transformation or change and providing the opportunity. In this space, there are people who will fall behind. There's no doubt about it. Not that everybody will make it. We have seen it. So those who fall behind it take decisions, and those who show real interest in transformation, help them and be patient with them. That's what I learned in this journey. Thank you. Any other question? Yeah.
Hello. I'm glad we brought up this question about are we making computers more intelligent than humans? And I would like to correlate it with something that you said about processes going to the cloud as well.
Yeah.
So you took the example of car assembly and saying that there are different parts made by different units maybe, and they just assemble it together. So if we are going to move processes to the cloud, where I as an employee will just need to work on a very, very specialized thing and not have the larger picture or focus on the larger picture, are we then actually accelerating the rise of computers? Because we are not going to be using our mental faculties as much, which is the primary cause of even the degeneration of mental capabilities, right? So I'm glad somebody brought it up, and although we have to accept change in the industry, the sad thing is it is driven more by bottom lines than to improve quality of life. So if the industry is going that way, what is the stance that we as responsible global citizens and owners of these technology are taking to make sure that it's a well-paced approach and perspective? Yeah. The second question I have is, we are already seeing cognitive computing. Even when I browse the internet, I visited a website, and the advertisement for that brand comes up on my Facebook wall. It's already happening. It's already making inroads into my personal space. So when you talk about analyzing data, the big data for cognitive computing and artificial intelligence, is it going to actually encroach upon concepts like GDPR and personal space and privacy?
Okay. Okay, I'll take the first one. Keyori can take the second one. Then first one is, one of you can also add. The first one, you need to acknowledge there are two things. The business process going to the cloud, no doubt about it. So that takes a lot of time, from custom process to industrialized process to platform-enabled process. Today, we are also going through customized process for each client. It's not sustainable, it's very costly, and customer never get benefit out of it. So we are industrializing process, whether it's procure to pay or order to cash or insurance management, we are industrializing it. Then we are putting in a platform, and that platform we are taking to the cloud, so that the unit of cost and velocity, everything is faster. So that customer is getting benefit, we cannot stop it. That's reality. Then you as a business process professional, your job is to really help the organization to industrialize these products, which is highly customized, and help the organization using cognitive concept and platform it and take it to the cloud. That's what we are helping our customers. Then the next concern you had is if employees are focused on task, they're only seeing the small parts of the small business, not the big part of it. It's true and not true also. In my people supply chain management role globally, what we have transformed over the last 2 years, looking at every employee, not from employee perspective, but 4 subcomponents: skill, will, task, and time. That's what we are looking at. For example, my Tej, my colleague is there. The day I understand Tej from his skill and will is his energy or passion, engagement, and what are the tasks he can perform, and how much time he takes to perform that task, how much I can eliminate, how much I can automate it, how much I can use cognitive platform is a success. So in this journey, Tej need to help me in terms of task and time and skill and will management. Then yeah, the employees who are performing task level cannot be successful until they understand the end-to-end process. So it is not simple task you can perform without understanding end-to-end process. But the day you manage a process at a task level by eliminating unwanted task, repeatable task, then only keep a core task which is essential for end-to-end business, you as an employee will be successful, customer get greater benefit out of it. That's what every industry is moving towards that. With that, Keyur, anybody want to add on this concept of process getting into cloud and manage at a task level?
Yeah, I mean, in a little broader context, I would like to say this: if let's say process got automated, right, and then I mean we are talking about the stuff that artificial intelligence systems are creating automation of many processes, and hence like employees' contribution would be shifted, right? If that is the context, then I would like to bring a point that no self-learned system is 100% accurate. Right? Because it is learning, and basically no human is 100% accurate, right? It's this, then it is subordinate of that. So definitely it won't be like totally deterministic, right? So we are moving from a deterministic era of programming to probabilistic era of cognition, right? So now whenever it is a probabilistic system, so any automation or any task that it is performing, it will perform with certain confidence, right? And whenever, I mean, all of us might have seen that Jeopardy episode where it says, what is Toronto? And then 5 question mark followed by that, right? So it is like that. I mean, it performs a task, then it will know, okay, what is my confidence level? If my confidence level is low, then that's when the human intervention is needed, right? Because if we want to categorize errors into 2 parts, let's say false positive, then it will keep on giving miss or pseudo or false alarms, right? We don't want that to happen. And if we talk about the other stuff, which is false negative, it can have a huge cost, huge implications. Detecting non-cancer to a cancer patient has its own cost, right? So these are the areas, the gray areas, where machine will also not learn in like at least like the few decades to come, right? So that's where definitely human intervention would be necessary to semi-automate the task. That's what I would augment, I mean, answer Sri's answer, yeah.
Okay, the big data one, did you answer it or want to take it up?
The second one about the privacy, right? So I'll just take a brief on that and then maybe, yeah, so definitely more and more data getting sensed. Let's say if I have Siri on my iPhone, then if it is on, then it is recording the data, right? So now what is the guarantee that it is not misused or it is not theft? So that's where I think this conference plays a huge role to create the awareness, right? Because many a time we download the applications in our phone, we don't even look into the permissions that is being asked, and we just say, okay, install, right? But it's not the case. One has to be aware about what is the intrusion that's been happening with the regulations and without the regulation as security theft. Yeah, so definitely it comes with a risk, and that's where our conventional security system will not be able to protect it, and that's where traditional security system has to move to cognitive security system. Just one difference. I mean, a conventional security system, if it is more of a reactive or more of a rule-driven, right, it will not be able to cover cases like this. So we need proactive, preventive and predictive kind of a cognitive security system, which takes this forward. I mean, we are using, in fact, this kind of system. Just to give an example, we all maybe using our email accounts, right? So let's say Gmail, then the security is generalized when it asks for username and password. That's a generalized context on the security, right? Because it is asking for authentication. But the moment it detects a little bit of lower confidence, then it asks for CAPTCHA. Right? It used to, right? So then it has to prove, okay, you're human or not. Still, if it is not happy, then it will basically, ask for OTP verification. And all at the back end, what's happening is that my usage data is available, my spatio-temporal data is available with that, my keystrokes, right? The pattern in which I do the keystroking can recognize whether I am a legitimate email sender or not, right? So all this cognition improves the security layers, and hence it would protect us. So definitely security has to transition to cognition. Yeah.
Okay, thank you.
So this just one more point, right? So technology will always be ahead. And I think regulations, government, and the think tank approach is the other net around all this. And a good example of that is what happened in the WhatsApp, Facebook, and the Supreme Court case, right? Where is the data from WhatsApp being used for targeting? So I think those are things in the public domain which go along with any technology. Right, at the time of industrialization, people would have asked the same questions, we are going to go out of jobs. The same thing is happening today. Right? So I think there's a pros and cons of both sides. It has to be a balance. I think the amount of change, and it's like a disruption which is happening. Like the era of industrialization, you have an era of artificial intelligence coming up. So things will change significantly. And it's a question which is beyond not just in India, but globally elsewhere. So I think it's a job of government as well. I think that's where, associations like DSCI also come into picture, educating the government what is required, what is not required. Yeah, so.
Thanks, Priyank. So we'll take one more question, then we'll take a minute to summarize it. Sorry, maybe I'll take it offline. You can talk it. Somebody, last question, then we'll summarize quickly. Yeah, go ahead.
Hi, are you able to hear me? So yesterday we had a session on GDPR, and it was very brain-bending thing. So with it coming in effect from 2018, two main points which I recollect from it are we cannot retain data indefinitely. And another is a user has a right to opt out of that. Now, if we combine it with machine learning and all these things, so now, in essence, machine learning works on big data, and we derive some models out of it. So, I mean, if we combine it with this GDPR, so now, in essence, we are saying we have to lose that data. Then here the edge on which machine learning works, we are losing it. And second is, if we say we want to opt out of it, then we are getting some knowledge or learning from the data. How can you remove that knowledge from that model, which is being learned from that big data? So do you think it is a challenge, and how it can be balanced?
Well,
yeah, sure.
Very small point. We have SMS opt-out. I don't think it's working. Right? We have SMS opt-out in India, regulated, everything. So I think some of these opt-out mechanisms work only when enforced by the regulatory body. Right? So that aside, I mean, what you're asking is a valid point. Right? But I think, that's, again, it lies in with, as systems understand why you're opting out, they will improve better, right? So when you unsubscribe from some email list, they ask you, why did you leave? I don't know if anybody's using that information today, right? But organizations do ask for NPS and what did you like and don't like, and some organizations do act on it, and you see improvement in quality in sometimes. Right? So I think it goes both hand in hand. I think it's not just about, I think the big data systems have not been applied to that yet. So it's not a big enough problem.
Okay, thank you. So let me take a minute to summarize it. Keyur, you hit a very wonderful point. Machine learning requires interface between human and machine. It's machine alone cannot learn. So when I started my journey of understanding machine learning and cognitive computing, I went back and looked at my books of earlier days as a student of psychology. I find a very interesting article. I recommend you should read that. That's the spirit behind cognitive computing. It's called Kolb's learning cycle. In Kolb's learning cycle, it's called experiential learning, have 4 dimensions of learning. That's what machine does faster than human being. But human being supposed to do it, but because of our own bias and lethargy, we don't do it. The first one is every one of us and machine go through a concrete experience. This concrete experience can be managing a ticket or answering to a customer call center or whatever it may be. The machine and human being gone through concrete experience. After this concrete experience, you have to go and reflectively think How was my last concrete experience with a customer or an event or a task or a process? That's the second step of machine learning. The third step of machine learning, based on my concrete incident or experience, I reflectively learn and think, then I make an abstract concept out of it. This is the right way of doing it. Then the fourth stage is active experimentation. When I get an extra opportunity of doing the same task, I put my abstract concept, which I learned from concrete experience and reflective observation, into practice. That give me next concrete experience, and that cycle continues. But we have seen human being doesn't go through this cycle, not all, few people. We have a concrete experience, we'll forget. We don't go through reflective observation and abstract conceptualization and active, but machine does it wonderfully. So machine, whenever get a concrete experience, it reflectively think through an algorithm and pattern, then it make a pattern, abstract concept, and it experiment next to transaction. So that's the reason machine learning is very efficient. With a human interface, it makes perfect. So that's the first key takeaway. Second one is machine learning or cognitive computing is real. Doesn't ignore it. Embrace it, and it is penetrating faster than any of the technology era we have gone through it, including internet or client-server computing. It's penetrating very fast. That's the reality. The third one is companies and my customers really confront three things in their business. How do I run traditional business of infrastructure, application, business process? We call it as run with the tranquility. Second one is how do I renovate new contracts with the better offerings for my customers? The third one is how do I reimagine using technology and creativity? The Googles of the world and Amazons of the world use technology or Uber, and with the creativity, they come up with a fantastic offering. So how do you do that? The last one is not only we need to embrace it, the cognitive technology or computing, the customers are embracing it faster. They're very comfortable to talk to a chat box or a Siri or a robot. They don't care whether it's a human being. They're very comfortable. They're enjoying that transaction or interaction. And that's where the adoption comes very fast. With that, Partha, Priyanka, and Keyur, thank you very much for Intersight. And you have been a wonderful audience, and thank you very much.